This is the third lesson from Unit 5 and on perpendicular lines. And I don't always show the warm-ups, but I think this one is particularly relevant for this. It asks you to find the slope between 2 points and then graph the points and find out what you notice about the angle of where they intersect. So pause the video at this point and perhaps try this question. So to do this, to find the slope, what we do is y2 minus y1 over x2 minus x1. So make sure you label your points. The first coordinate being x and the second one being y, and this is our first y coordinate, this is our second y coordinate, and then we plug the numbers in. Remember, when we're substituting, we need to put parentheses around any negative numbers to avoid any mistakes. So the answer to our first question was 6/8 or 3/4, and when we did it for the second one, we ended up with -4/3. Now you were also asked to plot those points to see what you noticed, and when you plotted them, what you should have found is that they actually intersect at a right angle. Now it might not be very convincing from my graph, and that's probably because these aren't perfect squares as I did them. But if you use proper graph paper, then that's what you should have found. And the reason for this warm-up is, that's the definition of perpendicular lines. Lines that intersect at 90 degrees. So actually all of these angles should actually be a right angle. Now, how are we going to answer those questions? Well, last lesson we did parallel lines where the slope was the same, and this time we're going to do perpendicular lines that have slopes that are negative reciprocals. Now, some people like to use the phrase opposite reciprocals, and sometimes that might be a better phrase actually, because if something is negative and we do the negative of it, it changes it to a positive, and if we use the word opposite, the opposite of negative is just positive, so sometimes that helps. Reciprocals when you have a fraction and you flip the fraction over or do 1 over that fraction. So think in your head when you're doing this question, flip the fraction, change the sign. So if I said perpendicular to 2/5, I would flip the fraction, so it becomes 5/2, and then change it, so from positive to negative. And this would be the slope that's perpendicular. Now to practice that, I had a few examples here. So 3/2, I would be flipping it to make 2/3, change the sign, so negative. 2/5, flip it, 5/2, change the sign to positive. If it's positive, notice we're not actually going to put positive there. Now if it's a single number, it's much more difficult to flip. So like we did with rise over run, you can always make it over 1 if you want to. So flip it, 1/3, and then change the sign, -1/3. 1/2, flip it, 2/1, and 2/1 you can simplify to just 2. Change the sign, so make it positive, so just 2. -4, we can put it over 1. Flip it, 1/4, change the sign, positive 1/4. 1/7, flip it, 7/1, which is just 7, change the sign, -7. And 0 is the one we have to think about a little bit. You can put 0/1, and then when you flip it, you get 1/0, and then when we change the sign, we get -1/0. If you work out -1/0, it says math error. And the reason for that is because it is undefined. And this is one of your special cases. If you have a slope of 0, it goes like that. So the one that's perpendicular to that is a vertical line, which we should know has a slope of undefined. So that's how you're going to work out what the perpendicular slope is. Make sure you check carefully if it does say parallel or perpendicular, because obviously they're different rules. So if I give you the equation of a line, like we had last time, if we find the slope of a line, we're just looking for how many x's it is, as long as it's in slope-intercept form, i.e. y equals. So the slope for this is -5. So if I find the line parallel to that, that means it has the same slope. And if I want to do the perpendicular one, this is where I do the switch. So I flip the fraction, 1/5, and I change the sign. So -5 becomes positive 1/5. If I have x minus 2, then there's no number here, which means I can write this as 1x. So therefore, my slope for this question is 1. The parallel slope is the same, which is 1. And when I do the perpendicular one, this is where I have to do the reciprocal. So I can write it as 1/1. When I flip it, I still get 1/1, so in other words 1. And then I have to change the sign, which is -1. So that one can be a little more complicated. Oops. And for the last one, 1/4 x, so the slope is 1/4, because it's the number of x's, it still is slope-intercept. Parallel to this would also be 1/4, and then perpendicular to this, flip it, and change the sign. And even better for this, negative 4 divided by 1 is just negative 4. So let's just put negative 4. Now when it comes to answering questions, you're going to be using that method of point slope again. So we're always going to be given some sort of point, and we're also going to be given some sort of equation and told that it's perpendicular to this. So the slope for this line is negative 1/3. Therefore the perpendicular slope, if we flip this, is 3 over 1, or 3. Change the sign, so negative to positive. And then now we have the same information we had in the last two lessons. We're given a point, and we're given a slope. Whoops, that's supposed to say x1, y1. And then we can go ahead and start filling in our equation. So y1 is negative 1, so when we subtract a negative, remember that becomes a positive. And the slope was 3, and then the x value was 2. Distribute, and then subtract 1 from both sides. Now it says write an equation, so it doesn't ask which form. So this would be the point slope formula, and that might be sufficient for this question, or it could ask us to go into slope intercept form, which would start with y equals. If it asks us to go more complicated than that, asks us to go for standard form, then I need to bring x and y to the same side. So I can subtract 3x from both sides. So I get negative 3x plus y equals negative 7. And then I'm not allowed any negatives in slope in standard form either. So I can change the sign of every term just by dividing by negative 1 throughout. So just make sure you answer specifically what the question asks. This time it says perpendicular to 2x minus 11. So the slope of this line is 2. And then the perpendicular slope, if I write it over 1, then I can flip it, and I can change the sign. So this is my value for m, the perpendicular slope. This is x1, this is y1, and then I can substitute in. So y1 is 5, x1 is negative, so if I subtract negative 4, that's going to make a positive 4, and I substitute it for my slope here. Distribute here, negative 1/2 x times x is negative 1/2 x, and negative 1/2 times 4 is negative 2, and then if I add 5 to both sides, I got my equation in slope intercept form. Now the last two are those special cases again. So y equals 2, we should know by now, is a horizontal line, and therefore the slope of that line is 0. Therefore the perpendicular slope would be undefined. Because this is a horizontal line, so a perpendicular line would be vertical, which would be undefined. Now if we have an undefined line, that means the equation is the form x equals. So I can write x equals straight away, and I just have to look what is my x value, and you can see quite clearly it's negative 4. So quite a simple question, but one a lot of students actually make mistakes on and get wrong. Similarly, if I ask you perpendicular to x equals negative 1, then x equals negative 1 is my vertical line, which means it's undefined. And perpendicular to a vertical line is a horizontal line, which is a slope of 0. And for this one, anything that has a slope of 0 is an equation y equals a number. So I can write y equals, and then I can just copy down a number, y equals 5. Now I could actually draw this on a picture as well, just to try and prove this. So it says it goes through negative 4, 5, which would be like somewhere here. So my original line was undefined, but I got to do perpendicular to that, which is horizontal. So it's going to be horizontal and going through this point. And although my picture's not brilliant, you can see that it hopefully goes through 5 on the y-axis, indeed making this equation y equals 5. Now the last thing you can be asked to do is to say if something is perpendicular, if it's parallel, or if it's neither. So if we have the same values like we do here, then we can say that this is parallel. Clearly number 2 is not parallel, so the other thing we have to check is it perpendicular? So 2 is 2 over 1, flip it, change the sign, and that's clearly not the slope of this one, so therefore this one would be neither. If we scroll down a little bit, clearly these are not the same, but negative 3, which we can write as negative 3 over 1, flip it, change the sign, you can see that these two are the same now, which means this is perpendicular. Y equals 3 is a special one, so we need to know that's a horizontal line. X equals 2 is a vertical line, and they are indeed at 90 degrees to each other. So this one would also be perpendicular. Now the question's much easier to tell when it's in slope-intercept form, because they could also be in standard form, and for that we would have to rearrange the equation. So make it say y equals, so subtract 2x from both sides, and then 3y equals 12 minus 2x, and then I can divide by 3. So y equals 12 divided by 3 is 4, and negative 2x divided by 3 is negative 2/3 x. So the slope for that one is negative 2/3. Now for this one, if I subtract 6x from both sides, and then divide everything by 9, 18 divided by 9 is 2. Negative 6/9 is the same as negative 2/3, and you can see that we have exactly the same slope for this, so therefore number 5 would be parallel. Do the same thing for number 6. Subtract 3x from both sides. So I got negative 2y equals this. Divide everything by negative 2. So I got y equals 12 divided by negative 2 is negative 6. Two negatives cancel, giving me a positive. So I got positive 3/2x. If I do the same for this one, subtract 4x from both sides. And then now divide by 6. 12 divided by 6 is 2. And negative 4/6x is actually the same as negative 2/3 x. Now you can see these clearly are not parallel because I got positive 3/2 and I got negative 3/2, negative 2/3 looks like this one. But notice if I flip this I get 2/3, and if I change the sign I get negative 2/3, which is what my other equation is. Therefore I can say that these two equations are perpendicular. And if we move down to our last one, so I can subtract 2x from both sides. So I get negative y equals 12 minus 2x. But I don't want negative y, I want positive y, so change the sign of everything. And we can see the slope of this one is 2. Now if I rearrange this one, if I add 4x to both sides, I get negative 2y equals 8 plus 4x. Divide throughout by negative 2. I got y equals negative 4 minus 2x. Now we've got to be careful on this one that we don't say that these are parallel. This one's a slope of positive 2. This one is a slope of negative 2. So they say they're not parallel, they're not the same. Now if I look at this one though, 2, and do the negative reciprocal, so flip the fraction, change the sign, we can see that it's not the negative reciprocal either. So this one would be neither. But be very careful where you've got one that's a positive number and the other one is the same number but negative. It doesn't mean that it's parallel, and it doesn't mean that it's perpendicular, but people often get tricked into putting that. And that concludes the work for Unit 5, Lesson 3. And that should enable you to go ahead and finish the rest of the Practice 6.5 worksheet.